Hey, physics games. What I want to do today is I want to do a couple things with you. One, I want to go over that problem that you just saw. I'll get it back up there here in just a bit. And I want to go over page 1 of your worksheet. So before you watch any more of this video, make sure the first page of your worksheet is done. That way you can kind of check your thinking with my thinking. All right? I want everybody to get 100% on that first page, but it won't do you much good unless you make your brain work a little bit and try and get that page 1 done. Okay? So what we're going to do first, though, is I would like to do this problem with you. Oops. Again. I'd like to do this problem with you and work it out. All right? Something a little bit more difficult. All right? So pause the video and give this one a shot, and then I'm going to work it out. All right? Okay. All right. So I assume you have given it a good old-fashioned try, and if you haven't, then you're not going to really know what the crap's going on. All right, so first things first, let's go ahead and kind of draw this thing out. It looks like I have bought the world's largest, let's get this so I can kind of work at it, the world's largest pudding cup, 189 pounds. And I pick it up in Salina, Kansas. I'm going to slide it down a loading dock into my truck. The ramp makes a 30 degree angle below the horizontal hill and 3 meters long. It says, what is the network done on the pudding cup if the coefficient of kinetic friction is 0.25? All right, so first things first, let's draw this sucker out. All right, I don't know if my angles are going to be exactly correct, but the Kimbriel pudding cup right here, yep, and so that's my 30 degree angles there, and I'll try and keep this straight for you as best as I can. All right, so this thing weighs what is it, 189 pounds. And we have a coefficient of kinetic friction. Do we have any other forces we need to list on this for right now? No, we don't. So here's what I'm going to do. I'm going to go ahead and I'm going to right triangle this thing off because I know, based on this problem, I'm going to have to right triangle this thing off. It's a little rough right triangle, but it'll work. All right. This is going to be synonymous with our normal force. This is going to be synonymous with the force that's being applied. All right. So here's what I'm thinking on this. I'm thinking there's a force applied here. I'm also thinking there's a counteracting force of friction since they gave us a coefficient of kinetic friction here. So here's my overall game plan here. Now I'm going to put that up here. The net work is going to be equal to my net force times the distance. So what we really need to work our way up to is we need to find the net force with all of this crap going on here. All right? So I know that net force is going to be equal to the force applied minus the force of friction. All right, so let's find out force applied. Let's find out F of K. I think we got all the information here that we need in order to pull that off. All right, so this is my force applied right here. All right, and we know that this is 30 degrees. All right, based on what it's in the problem. So let's do this. Let's put in here the net force is equal to the force applied. What's that going to be? mg, is that going to be sine of 30? I believe it is going to be sine of 30. All right, that's force applied. Minus F of K. All right, let's do a little thinking on F of K over here. The coefficient of kinetic friction is going to be something that looks like this. Yep. And so F of K is going to be this times this, just rearranging. My normal force I know it will be this line right here. All right, and I think that is mg cosine of 30. So let's put all this in. Let's put in this times mg cosine of 30. All right, so far so good? You guys feeling pretty good about this? I hope you are. Let's plug in some numbers, shall we? Mass, fart, that's pounds, 2.2. Where's my calculator? Calculator? There it is. All right. So 189 times 2.2, so that's how many kilograms it is. All right, let's go ahead and take that times 9.81. Let's get this thing rolling. So I got 4078. I'm just going to say 4079. So this is 4079 newtons. That's going to be F of G down here. All right, so I'm going to plug that in for my mg. So we got 4079 times the sine of 30 minus 0.25 times 4079 cosine of 30. All right. So if you watched me, I did that pretty fast, but if you watched me do it, I feel like I did it pretty good. I was kind of watching myself. So we got 1156, sounds good. Something like that? Yeah? Alright, now let's take that and plug it into our work net. So, oops, that's bad. Is equal to 1156 times the distance of 3. And 34 something. 3468 joules. How many sig figs we get? 2? Oh, what a load. Alright, so 3.5 times 10 to the third joules. How'd you guys do on that? Alright, hope I did that right. I feel like I did. Okay, alright, next thing on the list. Let's do this right here. Okay, so I didn't think this was too bad, really. I think a lot of it's just common sense. So if you don't have this worksheet done, pause the video and come back. All right, work through this, and then you can kind of check yourself as we go. I say, what's the work done on the crate by the force F? So that's this F. All right, I think that's pretty simple. The work is going to be that force times its displacement. All right. I don't think there's anything we need to do other than that. It just asks what's the work done. So it's FD. Next question, what is the work done on the crate by the gravitational force exerted by the Earth? So that is going to be this line right here. All right, and did they give us an angle? 30 degrees. So the work done by that is going to be mg sine of 30 times the displacement. All right. Next question, what is the work done by the normal force with this magnitude of F? Oh, this is a stupid question. There's no work done. It has to be parallel to the direction. Perpendicular forces are not going to do any work. It has to be in the same direction that the movement is occurring. So there's no movement, no work, no displacement in the perpendicular. It's not sliding this way, it's sliding this way. So that's none. All right, that's easy. What is the work done on the crate by the frictional force F of K? I don't think we need to overthink this. I would just do this equation right there. I mean, we could put a whole lot more here, but they really don't give us a coefficient of kinetic friction. So I'm just going to say your frictional force is going to be equal, or your frictional work is going to be your frictional force, and whatever distance it goes. All right, what is the total force acting on the crate? Let's double check here. A crate with a mass of N is on a ramp inclined 30 degrees, a force of magnitude F directly repelled on the ramp used to pull the crate with a what is the total force? That means F of net. Nothing. Constant speed. Constant speed means there's no acceleration, no change in velocity or direction, so nothing. And if that's nothing, then that's nothing. How about that? Well, there you have it. All right, you guys. We will be doing some Q&A later on as well. I'm probably going to give you, where's that one I just worked through? This thing. I'm going to give you one like this again, and probably not going to work it out for you, and I'm going to have you submit your answer something like this. Okay? All right, you guys. We'll see you later.